All right, on questions 30 and 31, there's actually two possible answers. I'm going to go with the one that um, you likely would have got if you thought this one through and identify this first thing as an acid. But I'm going to go ahead and show the second one here in just a second. So, and I'm going to combine them both because technically in the first one it just wants us to write our equation, and then part 2, 31, it wants us to actually tell you um, which direction of the equilibrium the reaction's facing. So I'm going to start this with my harpoon arrow, and then I'm going to come over here and I'm going to treat the CH3 as an acid, so I'm going to have it give up an H, and it will get donated to the NH3. Alright, now to decide which direction the arrow is going, we have to identify which component is acting like an acid and which one's acting like a base. Now, we just decided by stating that was an acid, therefore this is a base. And then over here, the base turns into an acid, and the acid turns into a base. And we have our acids and bases labeled on each side. Now, to figure out which way the arrow's going, we want to look at the Ka's of our two acids. And my two acids in this problem, one of them is CH3COOH, and the other one is NH3. And if I look at pKa's for those species, this one's going to be around 4.5 to 5, and this is going to be around in the 40s. So therefore, that is a stronger acid than that. And we know that whichever side has the strong acid on, the forward reaction for it is going to be stronger in the backwards. So my arrow favors going forwards in this problem. All right, there is a chance when you were writing this, you chose to make the NH2 minus act like an acid. And technically you're allowed to do that because both of those species in this balance equation have H's. So we at least have to consider the possibility of what happens if the H that gets donated came off the NH2 minus. Right, if it does get donated, that does mean that the carboxylic acid gets protonated, and our NH2 minus turns into NH2 minus. And I imagine if you were writing it, you probably stopped about there and rethought this, because this actually shows the CH3COOH behaving like a base. Something that we've called a carboxylic acid acting like a base kind of goes against what you might think of as rules. Then over here, that is our acid and base. But now if we wanted to rank the strength of our acids, we have a protonated carboxylic acid versus NH2 minus. This is definitely stronger. And because of that, this reaction favors going backwards. Matter of fact, it's such a strong difference, this one probably never goes forward, except maybe for one or two molecules inside a container.